All right, let's look at the Taylor Remainder Theorem. All right, so let's write out the terms of Taylor series. All right, so you have f of a centered at a. So f of a plus f prime of a times the quantity x minus a, and so on. And the nth one, nth degree one, is nth derivative f evaluated at a over n factorial times quantity x minus a to the n. All right. The sum of these first, in this case, n plus 1 term is called the Taylor polynomial. So we can call that Sn. All right. But remember that the Taylor series has infinitely many terms. So you have a whole bunch of, actually, there are infinitely many remaining terms. We're going to call those guys, the sum of those guys, Taylor remainder. So we're going to call it Rn. All right. Then Taylor remainder theorem says that there will be a number z between x and a such that Taylor remainder is actually exactly has the same value as f n plus first derivative of f evaluated at z. So this looks a lot like this term right here, right? The very first term of the Taylor remainder. But notice the difference. Difference is the original one you plug in the center. But this is not the same value as a. It says there exists some number z such that Taylor remainder can be written this way. All right, and the good thing about this is that once you have an expression for the Taylor remainder is going to be the error if you approximate the function by Taylor polynomial. So we can actually use this to find the error bound. All right. But anyway, so here, oh, actually, I messed that up. So this is actually not A. This is not C. This is A right there. All right. All right. So a little remark about the Taylor remainder theorem. If you look at the mean value theorem, if you remember that the statement is there exists some C between A and B such that the derivative of f at C is exactly equal to this difference quotient. Right? Mean value theorem is actually a special case of Taylor remainder. It's a Taylor remainder for R0. Right? So let me explain. All right, so I'm going to change notation. So instead of C in Taylor remainder, we're going to use Z. So I'm going to erase that and put Z in it. All right, and here I'm going to put erase that and put Z in it. All right, and instead of B, we're going to put X. So we're going to put X there. And X here and here. All right. Then I'm going to rewrite this a little bit here. So I'm going to multiply both sides by x minus a. So you have f prime of z times quantity x minus a is equal to f of x minus f of a. All right. And if you rewrite that and let's solve for f of x, you can just, let's say, add f of a to both sides. So you get f of a plus f prime of z x minus a is equal to f of x. Right? It's a little backward if you put it in the if you put the f of x on the left. So we have this. All right. Then you see that this is really the Taylor remainder theorem. You see that here, this portion is Taylor polynomial of degree 0. So this is just a constant. So this is going to be S0. And here, this is just a Taylor remainders theorem for R 0, right? Because in this case, n is 0, so derivative m plus 1 is the first derivative, so you have a first derivative, so you have a z there. And then, so 1 factorial is 1, so it doesn't show up there. And then you have a x minus a to the first power, right? So mean value theorem is really the Taylor remainder theorem for R0. All right, that's it. I hope that this was clear.